Today's video, I would like to introduce you a very nice problem of Indian Mathematical Olympiad, edition 1990, question number 2. Here is the following information. Find all pairs of non-negative integers xy such that we have this following equation: xy minus 7 quantity square equals x square plus y square. So in fact, this is a very nice equation, because the nice thing here, we are going to work on non-negative integers only. That's mean we are going to work on the positive integers, including 0. Okay, so this one is helping us a lot to reduce the number of solutions, because we have ignored the negative solutions here. So the second thing here, we have a nice symmetry here. Since we have this product xy, since we have this sum of these two squares, that's mean we have a symmetry here. Okay, so I would be recommend to give a try to this problem prior getting to the solution. Go ahead, pause this video when you come back to see the full solution. By the way, don't forget to support us with your like and subscribe. Now let's go ahead, jump into the solution. So since we have a symmetry here, without loss of generality, we have x, y is a solution. And also we have y and x is a solution because of symmetry. Okay, the second thing, assume x is inferior or equal to y. Okay, we would like to work on this direction. Okay, so at the end we conclude the other solutions as we have symmetry here. Okay, we are going to break this one into two cases: when we have equality, x equals y, and when we have x is strictly inferior than y. Okay, so if x equals y, I'm going to replace y with x here. My original equation becomes x squared minus 7 quantity square equals x squared plus x squared is giving us 2 times x squared. Okay, so I'm going to apply the square root on both sides. I will have x squared minus 7 is giving us square root of 2 is multiplied by x. Okay, we have the left hand side of this equation is an integer, but the right hand side of this equation is not integer. Okay, that's mean impossible. So this one is not a solution. That's mean we don't have equality. So this one is telling us that's mean x is definitely strictly inferior than y. Okay, so now I'm going to work on this order. So the next thing here, since we have this condition, I'm going to transfer this equation into inequality. Otherwise this equation become more challenged to solve it if we don't use the inequality here. Okay, if you take a look carefully at this equation, so we have xy minus 7 quantity square equals x square plus y square. Okay, this one is inferior or equal to x square plus y square plus 2 times xy, which equals x plus y quantity square. Okay, we have x y minus 7 quantity square is inferior or equal to x plus y quantity square. Okay, since we have this number is a positive, I'm going to take the square root on both sides. I will get xy minus 7 is inferior or equal to x plus y. Okay, and also we have this condition: x is strictly inferior than y. I'm going to add y on both sides. I will get here x plus y is strictly inferior than 2y. Okay, that's mean this one is strictly inferior than 2y. Then I'm going to move over this 2y to the left hand side of this inequality and move over minus 7 to the right hand side of this inequality to have the following expression. So we'll have xy minus 2y is strictly inferior than 7. Okay, this one equivalent. I'm going to take y as a common factor for the left hand side of this inequality. I'm going to leave this empty gap here. I will have y is multiplied by x minus 2, which is strictly inferior than 7. Okay, note if we have x is superior or equal to 2, this implies x minus 2 is superior or equal to 0. Okay, now the reason why I'm doing this one, so because I want to multiply both sides, by x minus 2, since this number is a positive, if x is superior or equal to 2. As we have this condition, so this term is superior or equal to x is multiplied by x minus 2. Okay? Otherwise, if we take in x equals 0 or x equals 1, this term become negative. If this term is negative, it is going to change the direction of this inequality. Okay? So that's why I put x minus 2 is superior or equal to 0. So that means this inequality holds since we have these conditions. Okay? Then I'm going to simplify these terms and take this 7 to the left hand side of this inequality. I will get the following expression. I will get x squared minus 2x minus 7 is strictly inferior than 0. Okay? For all x is superior or equal to 2. I have ended with this expression. Now let's set f of x equals x squared minus 2x minus 7. Okay? If I'm going to put this one in the graph, I will have upper face parabola. So we'll have number 1 here. So this function is going to cross vertical axis at the point minus 7, because if you take in x equals 0, is giving us minus 7 as output. Okay? So I will have minus 7 here. So this is the general picture for this function. Okay? Now I'm going to determine the intersection of horizontal axis and this function by solving this equation. To do f of x equals 0, we are going to keep this function strictly superior than 0. So our solution of this inequality is on this interval. Okay? So we'll have f of x equals x squared minus 2x minus 7 equals 0. The intersection of this function and the horizontal axis by solving this equation. Okay? So I'm going to calculate the discriminant of this one, which is delta. It's giving us 4 minus 4 times is multiplied minus 7. Is giving us 32. So we'll have x1 minus b, which is 2, plus square root of delta of this one, which is 4 square root of 2. Okay? Is divided by 2. We don't need another solution because we have a positive integers. Okay? So this one is giving us 1 plus 2 is multiplied by square root of 2. If we calculate this one, is giving us 3.82. About that. Okay? This one is 3.82. So that's mean the solution of this inequality on this interval, we have x is inferior or equal to, we have x from 0 to 1 plus 2 square root of 2. Okay? But we have taken this inequality on this interval, x is superior or equal to 2. So we must follow this condition. We must work on this condition. But x is superior or equal to 2. Okay? So that means x is going to take the following values, 2 and 3. So the rest of the solutions, x equals 0 and x equals 1, we are going to check it by hands. Okay? Because we cannot take x equals 0 and x equals 1 by using this inequality. Okay? Because we have this inequality is valid, we take it as x is superior or equal to 2. It might work, but it's not guaranteed. Okay? So that's why we have to check x equals 0 and x equals 1 by plugging it into the original equation to check if it has solution or no. Okay, I'm going to raise this board and take these values of x and continue solving our equation. Okay, previously we were working on this equation and came up with these values of x equals 2 and 3. I'm going to insert these values of x into the original equation to find y. Okay, so if x equals 2, by starting with the number 2, I will get here 2y minus 7 quadrant square equals 4 plus y square. So I'm going to simplify this equation. I will get 4y squared minus 28y plus 49 equals 4 plus y square. Okay, by moving over the terms, I will get 3y squared minus 28y 49 minus 4, which is 45, plus 45 equals 0. Okay, delta equals 208. It is not a perfect square. That means it's not a solution. Okay, the next case, if x equals 3, okay, I'm going to plug number 3 into this equation. I will get 3y minus 7 quinary square equals 9 plus y square. I'm going to simplify this equation. I will get 9y square. I will get minus 42y plus 49 equals 9 plus y square. By simplifying this equation, I will get the following: 8y square minus 42y, 49 minus 9, which is plus 40, equals 0. I'm going to divide both sides by number 2. I will get 4y square minus 21y plus 20 equals 0. By calculating delta of this one, you get 21 square minus 4 times is multiplied by 4 is multiplied by 20. I will get 21 square minus 320. If you calculate this one, is giving us 121, which is 11 square. That means a perfect square. So y, I will have two following solutions. Y equals 21 minus b plus square root of over 8 is giving us 21 plus 11, which is 32 over 8, which is 4. For y2 as a second solution, I will get 21 minus 11 over 8. 21 minus 11 is 10 over 8, which is 5 over 4. But this is not a solution because it's not an integer. Okay, so I'm taking only this value. Now I have the following solutions. I have x equals 3 with y equals 4. Since we have a symmetry here, I'm going to take the copy of this one. So the following solution becomes x equals 4 and y equals 3. So I have extracted only two solutions from this equality. So we have another solutions. I'm going to check x equals 0 and x equals 2 by hands to see it may be a solution or no. Okay. For other solutions with x equals 1, I'm going to replace x with number 1. I will get y minus 7 quinary square, get 1 plus y square. And at the same time, I'm going to simplify this equation. I will have y square minus 14y plus 49 equals y plus y square. I'm going to cancel out y square from both sides. I will have ended with the following expression. I will get 14y equals 49 minus 1, which is 48. By simplifying out number 2 from both sides, I will get y equals 24 over 7, which is not integer. That means it's not a solution. Okay, let's check the last case when we have x equals 0. X equals 0, I'm going to plug 0 here, is giving us 7 square, which is 49, is giving us 0. This one become y square. By taking the square root of this one, is giving us y equals 7. Since we have y as a positive integer, that means y equals 7. Okay, this is the solution as well. I'm going to add this solution. So we'll have x equals 0 and y equals 7. Since we have a symmetry here, also we have x equals 7 and y equals 0 is a solution. Okay, so 4 solutions are the only solutions that we have. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.